Hey guys, this is Parani from Great Learning, and I welcome you all to this session on data visualization with ggplot2. Now, before I start off with the session, I'd like to tell you that Great Learning would be coming up with a series of high quality tutorials on data visualization, machine learning, and computer vision. So please do subscribe to Great Learning's YouTube channel and click on the bell icon so that you get a notification of our upcoming videos. Now, let's have a quick glance at the agenda. So we'll start by understanding what exactly is the need of data visualization. And then we'll understand what is grammar of graphics. And finally, we'll see how to do data visualization with the ggplot2 package.
So what exactly is the need of data visualization? So let's understand this with this example over here. So let's say you're working on a huge data set of a car company, and the data set comprises of around 1 million rows. Now let's say if you want to understand the distribution of the price of different cars. So if you just look at the data set, would you be able to draw any sort of inferences? Well, obviously no. Now what if you had actually built a histogram for the prices of all of these cars? Then it would be very easy for you to draw inferences, right? So over here, if you see, you can easily identify patterns with the help of this histogram. And this is the need of data visualization, which I'm talking about, right? Now, also, visualization can be considered as a form of language. And I say that because with the help of data visualization, you can make the data talk to you. Now, also it needs to be kept in mind that every language has certain set of grammatical rules associated with it. And that is why, since data visualization is also a form of language, even it needs to have some sort of grammatical rules associated with it. So let's say there are two people, Sam and Matt, and they want to communicate with each other. And if they want to communicate with each other, then they need to know a common language, and both of them need to also follow certain set of grammatical rules to speak with each other. So let's say if I make a statement such as I like ice cream, then it would make complete sense because it follows the associated grammatical rules. But on the other hand, if I make a statement such as like ice cream then it will make no sense at all because it does not follow any grammatical rules. Now, when we talk about grammar, let's actually take the English language. So every word in English language is associated with something known as parts of speech. So you have different parts of speech such as nouns, pronouns, adjectives, verbs, and adverbs. And all of these different parts of speech play different roles in making up a complete sentence. And when it comes to grammar of graphics, so it basically helps us to divide our plot into different components. So you've got different components such as data layer, aesthetic layer, geometry layer, and so on. And when you stack all of these layers together, you get your final perfect plot. So let's understand all of these layers properly. So let's start with the data layer. So data layer is basically the data for which the visualization has to be done. So as simple as that. And once you choose the data for which the visualization has to be done, you head on to the aesthetics layer. So this is where you actually map your columns onto different metrics or scales. So you have different aesthetics such as the x-axis, y-axis, shape, size, color, and so on. So you can map your columns onto all of these aesthetics. So you have decided your data, and then you have also mapped your columns onto different aesthetics. So once these two are done, you can go ahead and decide the type of geometry which you want to build. Now, what do I mean by the type of geometry? So this is where you actually decide the type of plot. So you can have different plots such as a histogram, bar plot, scatter plot, box plot, and so on. So the data layer, aesthetics layer, and the geometry layer form the core components of grammar of graphics. And once you're done with these three layers, you can go ahead to the facet layer. Now, many a times it happens that your dataset would have a lot of numerical columns and a lot of categorical columns. And if you have to plot all of these columns onto a single plot, then it might lead to a lot of chaos. And this is where you'd actually want to subset your plot or divide your plot into different subgroups. And this is where facet layer comes in to divide your plot into different subgroups. And then finally, we have the theme layer, which is basically used to make our plot even more pretty. So you can add background to your panel, and you can also add background to your plot. So these are basically the different components which are present in grammar of graphics. Now we'll head on to ggplot2. So ggplot2 is completely based on grammar of graphics. So the GG in ggplot2, it actually stands for grammar of graphics. All right. So let's run to the main part and let's do some beautiful visualization with the ggplot2 package. Right guys, so this is our studio and our first task would be to install ggplot2. So I'll click on packages tab over here and then I'll click on install. So let me just give in the name of the package ggplot2, and all you have to do is click on this install button and it will be automatically installed. And since I already have ggplot2 installed in our studio, so I don't have to do it again. Now once you install the package, you would have to load the package, and to load the package you will be using the library function. So you'll type in library and then you'll type in ggplot2 over here, and you have successfully loaded the package. Right, so we'll be doing all of these visualizations on this car dataset over here, which has around 25 odd columns and 205 rows. Right, so you've got columns such as the number of doors of the car, and whether the engine is present in the front or back. Then you've got the car length, the car width, then you've got the mileage of the car in city and mileage of the car on a highway, and you also got the price of the car. So we'll be making some really beautiful visualizations on this car data set. So as I've told you, ggplot2 is based on grammar of graphics. So we'll start off with the data layer first. Now this is the command to start with ggplot2. So you'll type in ggplot, and as I've told you, we have to decide a data set which has to be mapped on the data layer. So since I want to do visualization on top of this car data set, I am basically mapping this car data set into the data layer. So this is my first task. Now this helps us to make a blank plot. So this is basically the first layer, and once this is done, I will go ahead and stack the aesthetics layer on top of it. So I'll put in a comma. I'll use the AES attribute, which basically stands for aesthetic, and I want to understand the distribution of the price column. So what I'll do is I will map this price column onto the X aesthetic. So let me just put in price over here. So I'll hit enter. Right, so I have successfully mapped the price column onto the X aesthetic. And what you see is the price of the car, it would vary between around $5,000 to around $40,000. Right, so we are done with the data layer and also the aesthetics layer. And now it's time to decide on the geometry layer. So since it's a univariate distribution, or I basically want to understand the distribution of just the price column, I'll go ahead and build a histogram for this. And to build a histogram, I would need the geom histogram function. So there are different geom functions over here for each type of geometry. If you want to build a bar plot, you've got geom bar. If you want to build a box plot, then you've got box plot, right? And since I want to build a histogram, I'll just type in geom histogram over here. And I have successfully built this histogram. So let me just zoom this over here. Right, now what we basically understand this, so majority of the cars, so there are around 30 or 35 cars whose price would be around $10,000, and there are very few cars. So if you take these bins over here, so there are just 3 cars whose price would be greater than $40,000. Right, now you are able to draw these inferences by easily looking at this graph. But if you are asked to understand the distribution of the price of the cars by just looking at the data set, then obviously that wouldn't have been possible. Right, now what we'll do is we'll add some colors to this plot. So let me go ahead, and what I'll do is I'll add a fill color. So fill color is basically used to add a color inside all of these bins. So I'll type in fill inside this geom histogram function, and the color which I'd want to give is, let's say, dark orchid 3. Right, so the color which you see over here, this is dark orchid 3. Now I will also go ahead and add a boundary color, and if I want to add a boundary color, I will be using the COL attribute, and this time the color would be dark orange. So I'll just type in dark orange over here. Right, so I have also added a boundary color. Now this warning which you see, right, stat bin using bins is equal to 30, pick better value with bin width. So by default you get 30 bins whenever you're plotting a histogram. But let's say if I want fewer number of bins, or if I want more number of bins, then what you'll do is you will go inside this geom histogram function, and you will just use this bins attribute and change the number of bins which are present in this histogram. So let's say if I want 50 bins, I'll just type in 50 over here. Right, so over here I have 50 bins. So this is how you can change the number of bins, and with the help of this you can basically understand greater variation. So let me zoom this over here. Right, so now you're able to understand greater amount of variation in this graph. Right, so Till now, what we've done is we have actually used the fill and call as attributes. But this color which is there inside these bins, I want that color to be actually determined by a column. So what I'll do is I will map a column onto the fill aesthetic. And I want this color to be first determined by the fuel type column. So let me actually show you the fuel type over here. So this is the fuel type column, and the fuel type could be either gas or diesel, right? So depending on the fuel type of the car, I want this color of the histogram to be determined. So over here, what I'll do is I will use fill as an aesthetic and not as an attribute, right? So you see this aesthetic function inside the ggplot2 function, right? So over here, I am mapping the fuel type column onto the fill aesthetic, and then the geometry which is used by me is obviously geom histogram. Now let me zoom this, right? So you have two colors over here. So the pink color is for all of those cars whose fuel type is diesel, and this blue color is for all of those cars whose fuel type is gas. And as you see, there are very few cars whose fuel type is diesel, right? So the count, or the bin size is quite less over here. And if you actually look at this far end over here, right, what you observe is if the price of the car is greater than $30,000, then the fuel type of the car would be mostly gas. Right? So there are no cars whose fuel type is diesel over here. And that's pretty much the same case over here, because we've got more number of cars whose fuel type is gas rather than diesel. So now, right, you are able to do all of this observation with the help of this. So going ahead, I will map the car body column onto the fill aesthetic. So this time I want the colors to be determined with respect to the car body column, right? So this is the car body column. So the car body could be either sedan, hatchback, so you've got other levels as well. So let me just plot it out over here. So these are the different types of the bodies the car could have. So you could either have a convertible, hardtop, hatchback, sedan, wagon. Now let's look at this. So this green color which you see, so this denotes all of those cars whose car body is hatchback. Now if we observe this part over here, so if the car body is of hatchback, then the price of the car would be somewhere around, let's say, around $5,000 to maybe $25,000. If you look at this far corner, so let's take this bar over here. So we've got just one car, and the car body is hard top. So if the price is greater than $40,000, we've got just one car and the car body is hard top. Now let's take this and this over here, right? So this again over here is a hard top type of car. So, and the price is very less. It's less than $10,000. But then again over here, we also have the car type of the car body to be equal to hard top, and it has the maximum price. So all of these inferences could be easily identified with the help of making this histogram. Right. Now again, I will map another column onto this fill aesthetic. So this time I want the color to be determined with respect to the engine location. So the engine location, so engine could be either present at the front of the car or at the rear side of the car. Right, so those cars for which the engine is present at the front, all of those cars have been represented with this pink color. And those cars where the engine is located at the rear, then it has been represented with the blue color over here. And again, there are very few cars whose engine is located at the rear and not at the front, right? So this is something we could identify from this particular plot over here. Right, so this was the distribution of the price column. Now I want to understand the distribution of the horsepower column. So let me show you the horsepower column over here, right? So this is the horsepower column and I want to understand the distribution of that. So again, I'll just map the horsepower column onto the X aesthetic, and the geometry is again geom histogram. Right, so what you see is there are majority of cars. So there are around 40 odd cars whose horsepower would be not even 50, right? So this would be around 40 or 45. And if we take this bar over here, so there would be around 25 odd cars whose horsepower would be around 90 to 100. And there are very few cars. So there are just actually two cars whose horsepower would be between 250 to 300. Interesting inference again. Now we'll just add the fill color and the boundary color to this. So this is the same previous command. What I've done is I've used the fill attribute and the call attribute over here. And the color which I'm mapping inside the fill is khaki 3, and the boundary color which I'm giving is lavender blush 4. Right, so this color which you see inside these bins over here, so this is khaki 3 and the boundary color is lavender blush 4. Right, so now again I want this color to be determined by a column. So I'll be mapping the cylinder number column over here onto the fill aesthetic. So I'll copy this command, I'll paste it over here. So I have mapped the cylinder number column onto the fill aesthetic. Right, so a car could have these number of cylinders. So it could have either 4 cylinders, 5, 8, 12, right? So these are the different categories. So let's take these green color bins over here. So if the car has 4 cylinders, then its horsepower would be mostly between let's take this as 0, so it will be between 0 to 110, right? And I'll take this. So if the horsepower of the car is close to 300, then the number of cylinders would be 2. So again, this would be around so the horsepower mark is around 250, and this indicates that the number of cylinders the car would have is 12. And again, interesting observation over here. So let's take this color over here. So this is for the number of cylinders to be equal to 6. So if the number of cylinders are equal to 6, the horsepower, it varies between 110 to around 210. Right, so this was a histogram, and with the help of a histogram, you were able to understand how does a continuous numerical value change, or we were basically able to understand the distribution of a continuous numerical column. Now, mostly people get confused between a bar plot and a histogram. So the difference is pretty simple. A bar plot is used to understand the distribution of categorical columns, and a histogram is used to understand the distribution of continuous numerical columns. So that's pretty much the difference. So now, since we're done with histogram, let's head on to its counterpart, which is basically the bar plot. And I would want to understand the distribution of car body column. So I have this car body column over here, which is categorical in nature, and I will go ahead and plot it. Right, so I have mapped the car body column onto the X aesthetic, and the geometry used by me is geom bar. Let me zoom this over here. So we see that most of the cars, either their car type or the body of the car, it's either hatchback or sedan. So there are around 90 odd sedans, and there would be around 74 or 73 odd hatchbacks. And the lowest count is of convertibles. So the number of convertibles would be around not even 15. Now we'll add a fill color to this again. So to this command, what we're doing is we're just adding this fill attribute, and the color given by me over here is pale green 4. So this color which you see over here, this is actually pale green 4. Now I'll also give a boundary color to this. So to add a boundary color, I'll just use this COL attribute, and the boundary color given by me is normal green color. Right, so this is the normal green color. Right, so I'll just go ahead and take up some of your questions. Right, so I have some questions over here. So the first question is, how can you change the bin size or width in a histogram? So I'll just check that out. So yeah, so I'll go ahead and map this. So this is your histogram over here, and if you want to change the bin size or the bin width, all you do is type in bin width over here, use this and change the bin width, right? So it's as simple as that. And so we've got another question over here. So from where can I find out the names of different colors used in ggplot? Oh yeah, right. So these colors which you're seeing now, you find these, the names would be quite funny. So if you want to have a glance at the names of all of this, just type in view and then given this colors. So the colors function has a list of the names of all of the different colors over here. right? So over here you can actually have a glance at the different colors which are present. Right, then we've got a question which basically states, can you map and show two categorical columns onto a scatter plot? Well, we've not yet read scatter plot, so once I reach the scatter plot, I'll definitely answer this. Right, so once we cover bar plot and when we reach scatter plot, I'll go ahead and answer your question. Right, so over here we were mapping the boundary color and the fill color, so this is done. Now again we will go ahead and map a categorical column onto the fill aesthetic over here, and this time I want the color to be determined by the doors column. So the number of doors, it could be either 2 or 4, right? So wherever you have this pink color over here, this would denote all of those cars where the number of doors which they have is 4, and this blue color denotes all of those cars where the number of doors are 2. Right, so if we let's take this. So if the car type or the body of the car is a wagon, then the number of doors it would have is 4. Now let's take this. So if the car body is sedan, then the majority of sedans would have 4 doors, and there are very few sedans which would have 2 doors. And if we actually take a hatchback, then the majority of hatchbacks would have 2 doors, and very few of them would have 4 doors. And a convertible and a hardtop would always have 2 doors. Right, now we'll do something interesting. So over here what we see is these bars are stacked on top of each other, but what I want is I want these bars to be stacked in alignment with each other or next to each other. So that is where I can use the position to be equal to dodge. So when I set the position to be equal to dodge, this is what we get. So initially these bars were stacked on each other, but I did not want that. I actually wanted them to be aligned next to each other, right? So over here for these three categories, these bars are aligned next to each other. So this is where we can use the position attribute inside the geom bar function. So this was the distribution of car body column. Now similarly I want to understand the distribution of the fuel system column. So let me just check where the fuel system column is. Let me go to this side over here. So where is the fuel system column? Right, so here we've got the fuel system column, and these are the different types of fuel systems which we can have. So it's MPFI, IDI, and so on. Right, now let's actually go ahead and make this bar plot. So I am mapping the fuel system column onto the X aesthetic, and obviously I'll be using geom bar because I want to make a bar plot. Right, so these are the different categories which are present, and we see that the fuel system for type MPFI, so there would be around 80 odd cars or more than 80 cars whose fuel system is MPFI. Then we've got, so the next highest is 2BBL, so there would be around let's say 65 or 70 odd cars whose fuel system would be 2BBL, and there would be very few cars whose fuel system would be MFI or SPFI. Now again we'll add some colors to this. So I'll add the fill color to be equal to violet, and the boundary color which I'm giving is tomato. Right, so this is violet and the boundary color is tomato. So that was quite easy. Now I want to add I want the colors to be determined by a column. So I will basically map the fuel system column onto the fill aesthetic. That is, on the x-axis we have the fuel system. So for each category of the fuel system column we'll have a different color. So we've got 1, 2, 3, 4, 5, 6, 7, and 8 different categories for fuel system. And since the color was being determined with respect to the same column, that is why we have 8 different colors for all of these 8 different bars. Right, now instead of fuel system, I want the color to be determined with respect to the engine type of the column. So I'll map the engine type onto the fill aesthetic. The rest would be the same in the command. So these are the different types of engine which the car could have. And what we see is there is a large proportion of this, green color. So this is greenish blue color over here. And this is for the engine type of OHC, right? So there's a majority of, type OHC over here, right? And if we take these two fuel systems over here, so if it's either SPDI or SPFI or MFI, then it's a guarantee that the engine type for these fuel systems would be OHC. And if we take this fuel system over here, 4BBL, so if the fuel system of the car is 4BBL, then it's a guarantee that the engine type would be rotor. All right. Now let's take this over here. So if the fuel system of the car is 2BBL, then there would be very, very few cars whose engine type would be equal to I. Right, so this was a bar plot. So we are done with univariate analysis. So we use histogram and bar plots for univariate analysis. Now let's say if I wanted to understand how does one variable change with respect to another variable. So this is where I can build a scatter plot. So with the help of scatter plot, I can basically map one column onto the y-axis and another column onto the x-axis and understand is there a relationship between these two variables. And when it comes to scatter plot, you normally use two numerical columns. So both y and x have to be continuous numerical columns. So that is why I want to understand the distribution between the price of the car and the engine size of the car. So I'm mapping the price of the car onto the y aesthetic and the engine size of the car onto the x aesthetic. And if I want to make a scatter plot, the geometry used by me should be geom point. So this is the code for this. Right. Now, if you look at this graph, you can see that it is sort of a linear relationship between the price of the car and the engine size of the car. So as the engine size of the car increases, the price of the car also increases over here. So let's take some arbitrary point. If we take this arbitrary point over here, so we can say that if the engine size would be around 190, then the price of the car would be around $27,000. Similarly, if we take this lowest point over here, so if the engine size, it would be around maybe not even 50, so that would, let's say, around 20, and the price of the car would be around $2,000, right? So it's a very simple observation over here. So as the engine size of the car is increasing, the price of the car is also increasing. So this was the basic plot. Again, since we like some fancy stuff, we'll add some color to these points. You have to keep in mind that when it comes to a scatter plot, you will not have the fill attribute, you will only have the call attribute. And that is because since these are points, you can only add boundary to this, right? So the color which I'm adding to these points would be yellow green. So I have successfully mapped the yellow green color to all of these points over here. Now I will go ahead and I want to determine the color of these points with respect to a column. So I will map the cylinder number column onto the call aesthetic. So rest is same. Price is mapped onto the y-axis, engine size is mapped onto the x-axis. The only difference is I want to determine the color with respect to the cylinder number column. Right. So as we see, we have a majority of green color points over here. So these green color points, this would denote all of those cars which would have 4 cylinders. So if a car has 4 cylinders, then its engine size is somewhere between 50 to around 150, and its price would range from around, let's say, $2,000 maybe to around $20,000. Right, so interesting observation again. And if we take these two pink color dots over here, right, so this would denote those cars which would have 8 cylinders and their engine size would be around 240 and their price is around $35,000. Right, so again, interesting observations. Let's take these 3 points. So here the number of cylinders would be this seems like, okay, seems like I've gone colorblind, so it's either this color or this color. So I'll take the number of cylinders to be 2. So if the number of cylinders are 2, the engine size would be around 50, and the price of the cars would be around $15,000, right? So these were some interesting observations. Now what I want is I want to increase the size of these points, right? So I just realized that I've gone colorblind and I was not really able to understand which color was what. So I decided to increase the size. So to increase the size, I just use the size attribute over here and I given the value 2. So as you see, the size has increased over here, right? So, well, we were actually right. So, the number of cylinders for this is 2. So this is how we can increase the size of it. Now we can also change the shape of all of these points. And I want the shape to be determined by a column. So what I'll do is I will map the fuel type column onto the shape aesthetic over here. So let me open this up. Right, so this is the column and I'm mapping this fuel type column onto the shape aesthetic. So rest is the same. So as you see, you have 2 legends over here. So this first legend, this denotes all of the colors. So the colors of these points is being determined by the cylinder number column, and then we've got the shape of these points, and the shape of these points is being determined by the fuel type column. So if the point is circular, then this would denote that these cars are of diesel type, and if these dots are triangular in nature, then this would mean that the type of fuel is gas, right? So as you see, there are majority of cars whose fuel type is gas rather than diesel. And again, if you look at this far end, then all of these cars are of gas type, right? So basically all of the high-end cars, seems like all of the high-end cars would have their fuel to be of gas, right? Yep, so this was an interesting observation. So we are done by understanding the distribution of price and engine size. Now we'll do something else. So this time we'll map the horsepower onto the y-axis and city mpg on the x-axis. So I basically want to understand how does the horsepower of the car vary with respect to the mileage of the car in the city. And again, the geometry used by me is geom point. So this time what we see is this is sort of an inverse relationship. So as the mileage of the car in the city increases, the horsepower of the car decreases over here, right? So I'll reiterate it, as city mpg increases, or the mileage of the car in the city increases, the horsepower of the car decreases. Now again, you are able to just identify this pattern by just looking at this graph. So this is how simple data visualization makes it work. Now since I don't like black color much, I'll change the color. I'll set it to be equal to rosy brown. So this color which you see is rosy brown over here. Again, since my eyesight is also weak, I'll try to increase the size of it and I'll set the size to be equal to 2. And also one additional thing which I'm doing over here is I am mapping the car body column onto the color aesthetic. So horsepower onto the y aesthetic, city mpg onto the x aesthetic. The color is being determined by the car body column, and the size over here inside the geom point, I'm setting it to be equal to 2. So let's take these points over here. So these are of green color if I'm not wrong, right? So what you see is these two cars, their car body is hatchback, and they would have the maximum mileage in the city, but their horsepower would also be the lowest. So you can take this point over here. So this again denotes a hatchback, right? So again, this is quite contrasting. So you've got one hatchback over here whose horsepower is maximum and the city mpg is minimum, and then you've got two hatchbacks over here which would have the maximum city mpg but the lowest horsepower. Interesting inference. So we are done with scatter plot as well. Now let's go ahead and make some line plots. So line plots are again used for bivariate distribution, where you map one column onto the y aesthetic and another column onto the x aesthetic. So this time I want to understand how does the car length vary with respect to the car width. So let me just open this up. So you've got where do we have car length and car width, right? So we've got car length and car width, and I'm mapping this onto the y aesthetic, and I'm mapping this onto the x aesthetic. And since I want to make a line plot, I'll just use the geom line function over here. So this again is not exactly a linear, but there is sort of a positive linear relationship between these two. So at least there is some sort of increment in the car length when the car width increases. But if we take this point over here, so there's increase in the car length, but after that, if the car width increases, the car length suddenly drops down. So again, you have a similar drop over here, right? So from 60 to around 62.5, if the car width increases, the car length increases from 140 to 165. So there's almost an exponential increase of car length with respect to car width over here. But after that, when you increase the car width from 62.5 to around 64, then again your car length drops down from 170 odd to below 160, right? So this was the inference from this plot. Now again, let's add color to this. So over here again, since this is a line, you will not have anything to add inside the line. So you'll just have the color attribute and not the fill attribute over here. And I want to give red color to this. So I'll just map the red color onto this color attribute. Right, so I've successfully given the red color to this line. Now I want the color to be determined by a column. So I'll map the fuel type column onto the color aesthetic. So the fuel type of the car, it could either be diesel or it could be gas. And this blue colored line, it would denote those cars whose fuel type is gas. And this red colored line, it would denote all of those cars whose fuel type is diesel. So as you see over here, if we take this diesel type of cars, then their minimum car width, it would be around 64 or 63, and their maximum car width would be around 71 something, right? And their car length, it would start at around 165 and it will go on till around 180. Right, so there's a greater distribution for those cars whose fuel type is gas, and there's a smaller distribution of those cars whose fuel type is diesel. So this was a line plot. Now again, let's make another line plot where we are trying to determine how does city MPG vary with respect to the highway MPG. So we are mapping the city MPG onto the y-axis and the highway MPG onto the x-axis, and the geometry which I want to build is obviously geom line. So this is quite obvious, isn't it? I mean, if you're driving a car and if you're getting a good enough mileage on a highway, then you must most probably get a good enough mileage on a city as well. So as you see, if the mileage of the car increases on the highway, then the mileage of the car would proportionally increase in the city as well. Right, so it's a direct linear positive relationship between highway MPG and city MPG over here. Again, I'll go ahead and add a color to this. So the color which is given by me is sandy brown. So this is the sandy brown color. Now again, I want to change this and I want the color to be determined by a column. So I want the color to be determined by the number of doors the car has. So I'll map this doors column onto the color aesthetic. So the car could have either 4 doors or 2 doors. So this blue color line denotes those cars which would have 2 doors, and this red color line denotes those cars which would have 4 doors. And as you see, there's a greater distribution for cars with 2 doors when compared to cars with 4 doors. Simple observation again. So this was a line plot. Now since I've told you that with the help of ggplot2 you can add stacks of layers on top of each other. Now what I want to do is I want to map multiple geometries onto the same plot. So I want a scatter plot and a line plot on the same graph. So it's quite simple. All you do is add in these two geom functions in the same command. So over here, I want to understand how does price vary with respect to engine size. So I'm mapping the car dataset onto the data layer. Then I map the price column onto the y-axis. I map the engine size onto the x-axis. And since I want a scatter plot as well as a line plot, I will give in both the geom point function as well as the geom line function over here. Right? So I've got both the line plot as well as the scatter plot over here. Quite interesting. Now, analogous to line plot, we have something known as a smooth line. So when you give a line plot, you basically have this straight line, but instead of a straight line, let's say I wanted, so let's say if I wanted a curved line over there, right? So that is when I could have used a smooth line instead of this. Right, so I just remembered that one of you folks had a question with respect to scatter plot, so let me just check that again. Right, so can you map and show two categorical columns onto a scatter plot? Yep, so I can, but then again, what you'll observe is it's not quite, that's not quite what you want. So I'll go back to my scatter plot over here, geom point, and let me add two categorical columns. So I will take engine type over here. So I'll just map engine type, and after engine type I will also map the cylinder number over here. Right, so I have mapped two categorical columns and I'm using geom point. Now you can't really understand anything, right? So all of these are discrete. So 8 is a discrete number, 5 is a discrete number, because cylinder number is a categorical column and then engine type is also a categorical column. So when you map two categorical columns onto the same scatter plot, you wouldn't really be able to understand anything over here. All right. So we were going through geom smooth. So let's go ahead with this. So as I was saying, if you don't want a straight line and if you want a smooth line, this is when you can use geom smooth. Now you must be confused what exactly is a smooth line, so I'll just plot it out and you'll see. So again, I basically want to understand how does the price of the car vary with respect to the engine size. So again, I am mapping two geometries over here. So first is the scatter plot, which I can get with respect to the geom point, and then I'll make a smooth line with the help of this geom smooth. All right, so as you see over here, right, so this is the smooth line which I'm talking about. So all of these points, this we've got with respect to geom point, and this is the smooth line. Now this smooth line, this will get, you have this warning over here, using method is equal to lowest. So this is sort of a regression algorithm, and it automatically applies this regression algorithm and you get this smooth curve over here. Now again, I want to change the color of the points and also the color of the smooth line over here. So I am assigning pale green 4 to all of these points, and I am assigning the orange color to this smooth line. Right, so now this is much more pretty than the previous plot. So we are done with smooth line as well. Now let's go ahead and make a box plot. So normally a box plot is used to understand the distribution of a categorical column with respect to a continuous column. So if you want to understand how does a categorical column vary with respect to a continuous column, that is where you will use a box plot. And over here I want to understand how does the price of the car vary with respect to the car body. So over here I am mapping the price of the column onto the y aesthetic, the car body onto the x aesthetic, and the geometry used by me is geom box plot. Right, so this is how a box plot looks like. Now a box plot gives you something known as a phi number summary. That is, it will give you the minimum value, the maximum value, the median value, 25 percentile, and the 75 percentile. So this what you see, this is the minimum value, this is the maximum value, this is the 75 percentile value, this is the 25 percentile value, and this is the median value. Now I know that this might be too much to consume for you, so what we'll do is we'll just focus on these median lines over here. And all of those people who are not from the statistics background, so median basically indicates the middle value. So 50% of the 50% of the quantity which is above the median line. So you can basically consider that 50% of the quantity is above the median line and the rest 50% is below the median line. So this is exactly the middle value over here. Now, if you just check these median lines over here, so let's start with this convertible type. So if the car is a convertible, then the median price of a convertible would be around, let's say, $18,000. And the maximum price of a convertible would be around $35,000. So now let's take a hard top. So if the car body is a hard top, then the median price would be $20,000. The maximum would reach around $45,000 and the minimum would be around $10,000. So there's a greater distribution of price when it comes to hard top type of car. And let's take this one, hatchback over here. So the median hatchback price would be around $10,000. So these dots which you see, so these are basically the outliers which are basically away from the norm right now. And if you basically want to identify all of the outliers, your best geometry would be to build a box plot. So when you build a box plot, you can easily identify if there are any outliers present, and I can go ahead and remove those outliers or actually change those outliers. So this was a box plot, and again, since I like prettier stuff, I'll go ahead and add some color. So I am adding this peach puff 3 color to the fill aesthetic over here. Right, so this color which you see, this is peach puff 3. Now I want the color to be determined with respect to the aspiration column. So I'll map this aspiration column onto the fill aesthetic. So let me open the data set over here. So the aspiration, it could either be standard or turbo. So as you see, for each of these boxes over here, right? So we've got car body on the x-axis. So for each type of the car body, you've got two different types of aspirations over here. So let's start with this. Now, if the car body is convertible, then the aspiration could only be standard. So you don't have a turbo aspiration when it comes to a convertible. Now let's take these two over here. So if the car body is a sedan, then the aspiration could either be standard or turbo. And if we take this, so the median price for a sedan whose aspiration is standard, it would be around $10,000. But the median price of a sedan whose aspiration is turbo, then its price would be closer to $20,000. Similarly, if we take this over here, if we take a wagon, then the median price of a wagon whose aspiration is standard, it would be close to $10,000. But the median price of a wagon whose aspiration is turbo, the median price would be around $20,000. So we are done with this. Now let's again change the x-axis and the y-axis values. And this time I want to understand how does the peak revolution per minute vary with respect to the fuel type of the car. So I am mapping the peak revolution per minute of the car onto the y-axis, and I'm mapping the fuel type onto the x-axis, and the geometry used by me is geom box plot. So as you see, the fuel type could either be diesel and gas, that's it, and the peak RPM, it's very obvious, isn't it? Right, so if the fuel type of the car is gas, then the median peak revolutions per minute for that type of car would be greater than $5,000. But if the fuel type of the car is diesel, then its revolution per minute would be around 1,000. Right, so there's a stark difference between these two fuel types. Right, now again I will go ahead and add some color to this. So what I'll do is I'll just set the fill color to be equal to salmon 2. Right, that's it. So we are done with the box plot as well. Now going ahead, I'll make an area plot. Now, so we've already built a histogram and that was used for univariate analysis. Now, the only difference between a histogram and an area plot is, so when it comes to histogram, you have bins depicting the distribution of a particular continuous column. But when it comes to an area plot, instead of the bins, what you have is an area depicting the distribution of that particular column. So I'll just print this out and I'll show you what I mean by it. Now I want to understand the distribution of the price of the car. So I'll map price onto the X aesthetic over here. And since I want an area plot, I'll be using this geom area method and I'll set the stat equal to bin. So when I set the stat equal to bin, this basically means that I want to do univariate analysis and I want to understand the distribution of a univariate column, right? So this is what we have when we build area plot. Now I'll also go ahead and again build a histogram for this. Let me show you the difference between a histogram and an area plot, right? So this is the histogram. Let me go back, right? So this is the area plot which you have, right? So this basically tells you the entire area covered by this particular column. So now as you see, so it's the same sort of inference over here. So there would be around 30 odd cars whose price would be between maybe $2,000 or $5,000 to around $15,000. And there would be very few cars whose price is greater than $40,000. Right, so this is how you can create an area plot. Again, you can increase or change the number of bins over here. So I am setting the number of bins to be equal to 45 and I can have a visualization of greater distribution over here. So instead of 45, let me just set it to be 75. Then I'll have greater distribution again, right? So again, I have a greater distribution over here. Now I will map some color to this. So I'll basically assign the yellow color. So I am mapping the yellow color to the fill attribute. Rest is the same, right? So I've also added this color. Now I want the color to be determined by a column. So starting off, I will map this fuel system column onto the fill aesthetic. Right, so this is a very pretty plot, isn't it? So as you see, there's a greater distribution of this blue color. Right, so this blue color, it starts at around maybe $2,000 and goes on by greater than $40,000. And this blue color is for the fuel system of type MPFI, right? So if the fuel system of MPFI, so for this particular fuel system, there is a greater distribution of price. Now let's take this brownish yellow color over here. So for this, the fuel system is of type 2BBL. And its price range would be around maybe $5,000 to $10,000. Again, we've got this pink color, so it's the same. So for pink color, the fuel system is 1BBL and its price range would be $5,000 to $50,000. Right, now instead of fuel system, I want the color to be determined with respect to the car body. So I'm mapping the car body onto the fill aesthetic over here. Right, so these are the different types of body a car could have. Now again, this blue color, there's a greater distribution of this blue color over here. So this blue color is for a sedan, right? So the price range varies a lot for a sedan. And again, if we take this green color, this is for a hatchback over here. So the price of a hatchback, it would be, let's say, $5,000 and it goes on till $25,000. Then you've got hard top, right? So you've got some amount of cars in the price range of $10,000 and you've got one car whose price is greater than $45,000 over here for a hard top, right? So this was area plot. So we are done with the basic components of grammar of graphics. So we are done with the data layer, we're done with the aesthetics layer, and we are also done with the geometry layer. Now, as I've told you, if there are a lot of components or a lot of variables, and you want to map all of those variables onto a single plot, then it would be quite cumbersome. So that is where we need to facet our data into subgroups. So let's do something like that. So over here, I am basically building an area plot. So this is the area plot for the same thing, right? Now, as you see, there are there are a lot of categories over here. Now, what I want to do is I want to divide these categories into different subgroups, and I want to divide them with respect to the car body column. So basically, I want to have individual areas for each category of the car body column. So what I'll do is I will use this facet grid function, and inside this facet grid function, I'll just given this tilde symbol and then given the name of the column, which is car body. So yeah. So what we've done is we have basically divided the first plot into multiple subgroups. So we've got different subplots for each category of the car body. So now the inference, so now drawing inferences from this particular graph could be very, very easy. So let's start with a convertible. So as you see over here, so we've got 3 peaks over here and 2 peaks over here. So the convertible's price, it could be between $10,000 to $20,000, but there is no convertible whose price range is between $20,000 and $30,000. Again, similarly for the hard top, the price of a hard top could be in the range of 10,000, and you've got nothing between 10,000 to 30,000, right? And if it's a hatchback, right, so you've got around 12 odd hatchbacks whose price would be around $10,000, right? And the maximum price of a hatchback could be around $35,000, and then you got no hatchbacks after that. So this is how you can facet your data and have some interesting observations. And then we'll head on to the final part of grammar of graphics, where we'll be adding some themes. So we will just start off by making a plot, and over here I am mapping the same thing, price onto the y-axis, engine size onto the x-axis, and I am making a scatter plot as well as a smooth line over here. Right, so the color over here, the color of the points is pale green 4 and the color of the line is orange. Now I want to store this in a new object and name this object to be equal to T1. And as I've told you, you can add multiple layers on top of each other. So T1 would be my first layer, and on top of T1 I will basically add a theme layer. So with the help of this theme layer, I am adding a background to this panel over here. So this, what you see, this is the panel and this is the entire plot. So I want to add a background color to this panel over here. So I'll just use this theme layer, and inside the theme layer I've got the panel.background attribute, and to this panel.background attribute I've got different element functions. So let me just show you. So if you want to make some modifications to an rectangular area, then you have element rect. If you want to make some modifications to some lines or grids over there, then you have the element line. And if you want to make some changes to the text to the present, which is present in the panel, then you can use the element text function. And since the panel is actually rectangular in shape, I will use this element rect function, and I want to give this a fill color of peach puff. So I have successfully given a color to this panel over here, which is peach puff. Now also I want to add a color to the entire plot. So what I'll do is I will store this in another object and name that object to be T2. So I basically have 2 layers over here, T1 and T2, and on top of T2 I will add another theme layer. So this time, with the help of this new theme layer, I'll be making changes to the entire plot. So since I want to add color to the plot, I'll use the plot.background attribute, and since the plot is also rectangular in nature, I'll use element rect, and the fill color given by me is salmon. Right, so this is what we have. So this is the background for panel, and this is the background for the entire plot. So now what we'll do is, going ahead, we will also add a title to this. So to add a title to the plot, we'll be using ggtitle. So for T3, I believe I have to store the previous command first. So I'll store it in T3 over here. Right, so now that we have T3, let me copy this again and paste it over here. So for this particular plot, I want to add a title, and if I want to add a title, I have this ggtitle function, and inside this I just given the title, which is price versus engine size, and I'll store it in a new object again. So let me print out T4 over here. Right, so I have added the title of the plot, which is price versus engine size. Now I want to adjust this. I actually want to center align this title, and I want to give a different color to this title. So to do that, I will add another theme layer on top of this, and inside the theme layer I will use the plot.title attribute. And since this is text, I will be using element text function, and I want to center align this. I'll use the just attribute, and I'll give the value to be equal to 0.5, with the help of which I can center align the text, and then I'll set the color to be equal to green. Right, so I have center aligned the text, and I have also set the color. Alright, so this was everything with respect to the ggplot2 package. Now we'll just do some additional plots with the help of Plotly. So the help of Plotly, you can actually make some interactive plots. So to work with Plotly, you'd have to load this up first. So I'll just type in library of Plotly. Now I'll make a scatter plot with respect to the price of the column and the engine size of the column, and this is the function for Plotly. We'll type in plot underscore ly, and you'll assign the car onto the data layer. Now this is how you assign the columns onto x and y axis. So you'll give in x, and then you'll use a tilde symbol, and then you will map the column. Similarly for the y axis, you'll give in equal to, and then you'll give in a tilde symbol, and then you'll map the column over here. Now let me just show you what is happening over here. So let's just wait till this opens up. Let me close this. Right, so as you see, this is an interactive plot over here. So if I put my cursor over here, this tells you that the engine size is 108 and the price of the car is 16,925K. Similarly, if I put my cursor over here, the engine size is 234 and the price of the car is 35,056K. Right, if I put my cursor over here, the engine size is 61 and the price of the car is 5,151. Right, so if you basically want an interactive plot, you can go ahead and use Plotly. Now I want to add a color to this, and the color needs to be determined with respect to the engine type. So I'll map the engine type onto the color aesthetic. Again, you have to remember that you have to give in this tilde symbol over here. I'll map this as well. Right, so you've got all of these colors. Now let me put my cursor over here. So this gives you three things. First is the engine size, which is 181. Next is the price, which is 19,699. And then you have the type of, so what was this? This was the type of engine. So the type of engine, as you see, this is OHCV. Similarly, if I put my cursor over here, the type of engine is OHCV, the engine size is 194, and the price of the car is $37,000. Right? So this was a scatter plot. Now let's go ahead and make a histogram. So it's the same thing, car onto the data aesthetic, price onto the X aesthetic. And if I want to make a histogram, I'll just use another attribute, which is type, and set the type to be equal to histogram. Right, so again, if I put my cursor over here, this tells you that for this particular bar over here, the price of the car, it varies from $18,000 to $19,999, and there are 11 cars between this price range. Similarly, if I put my cursor over here, there are 4 cars between the price range of $34,000 to $36,000. And then we'll go ahead and make the final plot for the day, where I'll be making a box plot. So I'm trying to understand how does price vary with respect to the car body over here. So I'll put my cursor on this. So as you see, so I had told you when it comes to a box plot, you had this 5 number summary. So you have the minimum value, you have the first quartile, which is basically 25 percentile, then you have the median value, then you have the third quartile, which is 75 percentile, and then you have the maximum value, right? So you have got the corresponding price values for each of these. So if it's a hard top, then the minimum price for a hard top would be $8,249. The maximum price for a hard top is $45,000, and the median price is around $19,000, right? So guys, this brings us to the end of the session today. So we comprehensively understood about ggplot2. So we started off by understanding what exactly is the need of visualization, and then we understood what exactly is grammar of graphics and how is ggplot2 based on grammar of graphics. And then we built a lot of plots. So we started off with histogram and bar plot, then we work with scatter plot, line plot, box plot, and so on. Then we learned how to facet our data, and then finally we added some themes to our data, right? And then we finally looked at some examples on how to work with plotly. Right guys, so this brings us to the end of the session, and before we actually leave, I just want to tell you that Great Learning, it offers a PGP course. It offers the Business Analytics and Business Intelligence course in association with Texas McCombs and Great Lakes. Right, so this is a 11-month course, and this course has been ranked as #1 analytics program in India. So the faculty members are world class. So let me just show you who will be the faculty members and the industry leaders, right? So you've got Dr. P.K. Vishwanathan, who has his PhD from Madras University. Then you have Dr. Kumar Muthuraman, who has done his PhD at Stanford University. Then you have Dr. Abhinandan Sarkar, who has his PhD at Stanford University. So you have all of these world-class faculty members and industry leaders who will be teaching you various concepts with respect to data science and business intelligence. So if you are looking to pursue a postgraduate course, then do check out this course page. Our counselors will get in touch with you. And if you want to get your career soaring in business analytics, please do reach out to us.
Right guys, so this brings us to the end of this session. So I hope that you've comprehensively learned about ggplot2 package. So thank you and happy learning.